Okay, let's go put this in our calculator. And one thing that I did during 5th period today is I changed my emulator to be the TI-84 Plus instead. And what it is I was using, before I usually use the TI-CE, like Kaylee has. But since most of you have this type of calculator, maybe you'll get more out of it. But do you know how to get these dots?
No.
What you do to get the dots, you press second format right here and go to grid on.
Wait, second format.
Second zoom. Zoom. Second zoom, see?
And wait, what?
Nice.
Second zoom.
Oh, cool.
Then you turn the grid on, and then when you turn the grid on, you'll have this looking thing. So what I'm going to do is go to enter this one, and I'm going to second catalog, enter. I'm going to enter x plus 2. Okay, I'm glad you guys are helping each other out. That's really good. Shows that you're such a good class today. That's really good.
Wait, I forgot to do the absolute values.
Plus, second, catalog,
But you forgot how to do it.
enter,
I got it now.
x minus 1,
You know what I mean?
Ooh, lovely.
and then we go ahead and put minus 2.
That's not gonna work for me.
There's catalog.
Yeah, it's at the bottom, the zero.
Go to Carol.
And then you go to zoom standard like this, zoom 6, and you have this looking thing here, right?
Wait, I
Yeah, it's math.
And to figure out what's going on, you can kind of look at this. You say, okay, it looks like we're decreasing all the way to maybe -2, then staying constant from -2 to 1, then increasing after 1, right? And how do you verify that? You can verify by looking at the table view, right? So you can see that the function is decreasing until x equals -2, staying constant until x equals 1, right? So -2 to 1 are the main things we're looking at here. So x equals, those are like our critical numbers. So we can say g of x is decreasing on what interval?
Negative infinity to -2.
Negative infinity, -2. Good to have Will back in the house today.
Yeah, Will.
And we are constant on which interval?
-2.
-2 to 1. Everybody agree with that?
Yeah.
And we are increasing on 1, infinity. Okay? So that is it. Somebody, if you could show Kayla about the grid, make sure she knows how to do that. All right? Okay.
Can you let me copy that down though, real quick, Mr. G?
Okay, we have this, right? Okay. Now, I have 2 former Algebra 2 honors students in my 5th period class who got this right. In fact, they were 7th period Algebra 2 honors students who actually knew how to do this without a calculator. So, I don't know, do you remember? Because all you guys were Algebra 2 honors students last year. Do you remember how to do this without a calculator?
Yeah.
Kaylee says, yeah, I don't remember.
I don't really remember that.
Okay, well, yeah, that's a long time ago. But let's go ahead and
Can I try?
you've probably all done this without a calculator. You want to try?
Yes.
Yeah,
Am I
so
supposed to run?
Katie's going to try to do this without a calculator. So the first thing I'm going to do before Katie moves it your parent function is going to be y equals x squared, right?
Oh, you're talking about that.
So here's y equals x squared. How do we transform this function?
Well, you're gonna go down because it's -1, so just go down 1.
Go down -1. Well, what I want to do is I want to save this for last, though.
It goes to the left by 2.
Okay, so goes to the left by 2. Angel, you sure about that?
Well,
Yeah.
that was squared, so does that matter?
So 1, 2. Okay, so we're to the left by 2. And then what else?
It gets
Vertical squeeze.
Gets wider, vertical compression or vertical squeeze, yeah. So compression will look more like this. Okay, and then Kaylee, what do we do next? We take it down 1, right? So it looks something like this. So allowing for inaccuracies in the drawing. So where are we decreasing? We're decreasing on where? -2. Okay, thank you, Adam, Angel. And increasing on everywhere else, right? -2. Kayla, did somebody show you how to do the grid?
Yes.
Great. Who showed her how to do that?
Caleb.
Oh, beautiful. Kaylee's on fire today. All right. Now this one here, but you remember the translation? Angel looks like he remembered, and Kaylee remembered the translating down.
I got
Somebody
it
else?
down, kind of.
Yeah, kind of.
I got it.
But this one is going to do what?
It's going to be negative.
It's upside down.
It's going to.
Upside down. So what I want to do is I want to draw the parent function first, right?
It's gonna reflect.
So the first thing, this negative sign will reflect, right?
Reflect.
So let's go ahead and reflect this guy. To reflect it, we still have to bring it down. So there's a reflection, right? What else?
And then we're going to go up to the right space.
Move to the right by 1? Okay.
And then we go up 3.
And then up 3, right?
What?
No,
Yeah.
No, it gets
negative.
smaller.
So our point here, our vertex is going to be the point 1, 3. Is that right?
What?
That's our vertex.
That's not right.
It's not right?
I don't
No,
know,
it
correct.
is. It is. It's in my calculator.
Yeah,
Also, that's how she'll figure it out.
should be right. Okay, so anyway, where are we increasing on this guy?
I thought you said we went over
Negative
two.
infinity to 1.
On negative infinity hasta uno, right? And we are decreasing on the other part. Yeah, 1, infinity. Any questions about the translation on this?
Yeah, why'd you go up there?
Yeah, 3. Because the 3 is not like connected to the parentheses, so it's pretty much like it's on the other side.
Yeah, so this is up 3.
Yeah.
And so,
That's just like.
but the way we did it in vertex form last year was this. Remember we had this, the standard form was a x minus h squared plus k.
Yeah.
Okay.
So they just moved the K to the front?
Yeah, so the k is moved to the front. So k equals 3 in this case. So it's just written in a slightly different format. Okay? But otherwise it's the same principle, right?
Yep.
Okay, good.
Next one's
Yeah, and not all these I'd expect you to be able to do without a calculator. Some of these you'll be able to do when you get into calculus without a calculator, but not before. Okay, this one here is going to look like, how can we do this one? Common factor,
Oh, it's like a little loop.
x, right?
That's put it down.
Then x squared minus x minus 2. So we're going to have x times, let's see, x, is it x minus 2, x plus 1? Is that what it is? Is that the proper factoring there?
Yeah.
It is? Okay, so I think we can draw it, like, sketch it okay, because we got our zeros here of x equals 2, right? X equals -1, good catch. And so we have, and we have x equals 0, right? So we have x equals 0, x equals 2, and x equals -1. And we know this is this a positive or a negative function? Positive. So positive odd will start low and end high. So we come like this, multiplicity 1. So it's going to look something like this, right? But what can we not see, really? We can't see from this sketch where this is. So really a calculator is going to be very useful to us, right? So let's go to the calculator. So we have x cubed, and it's going to be minus x squared minus 2x. Does that look right?
Yep.
And then we graph the thing. And so we got to find what these points are, right? How do we find that?
Go with the table.
Okay, go to second trace and you go to maximum. Okay, we want to find this maximum. Do you see where it says left bound?
Yeah.
Okay, what we're going to do is it says left bound, we got to go to the left of the vertex like this. And once we're there, we press enter. And now we see the question mark right bound. We go to the right of the vertex and press enter twice. And we get this value here. We get the x value and the y value. And so the y value is the maximum, and where it occurs is at x equals -0.55, right? So x equals, so we'll say x equals -0.55. So that's this one here, right? And then how do we find the other one?
Do the same thing.
Same thing, except we look for a minimum. And then we make sure, okay, get over here, we're to the left bound, right? Press enter and go to the right of the vertex, press enter twice. So here we get x equals 1.22, right? To round to the nearest hundredth. Is it helping you to go over this in the calculator? Is everybody seeing it pretty well?
Yep.
And make sure if you have questions about it, make sure you talk to a neighbor to get you to show this. Anywhere, we are increasing on what interval?
-30 to -0.55.
To -0.55. And then we're also increasing here, union
And then
1.22, hasta infinidad, okay? And then we're decreasing on just whatever's left, right? So we have -0.55, comma, 1.22. And would that be our answer here for this one?
Yes.
We'll make sure we come up here, have that. Yeah, it looks like it's all getting in the view screen there.
But I still write it down.
Still okay? So Adam, are you using the calculator on your phone? Oh, you got a, what app is that? Symbolab or
Count
Desmos?
84.
Okay, good job. Yeah, a lot of,
Because the Wabbit stopped working.
the Wabbit stopped working?
Yeah, well, there was a bunch of reviews saying it just stopped
Oh, really?
for everyone.
Okay, we are here to numbers 35 through 40, which comes to the concept of boundedness. And boundedness, I haven't talked a lot about directly in this class, but in the video lecture, part 2, remember that one I gave you the QR code for? If you watched that one, I discussed boundedness there, didn't I? So let's go ahead and do I expect everybody to remember? Or that everybody watched the video? No. I hope most of you watched it, but let's go ahead to this one. So we have y equals 32. So what does the graph of that look like? Yeah, constant, right? Y equals 32. So what kind of boundedness is this one here? Is this function bounded above?
Bounded on its domain.
It's bounded above and bounded below. So who said bounded on domain? Hannah, okay. Okay, Hannah is today demonstrating her greatness. Not that,
I think I need to start.
okay, bounded, we just say bounded.
Why don't you give us stickers anymore?
Well, part of the reason, I want to do it, but part of the reason is that I don't want it to interrupt the video that we're making directly.
It's interrupting the video right now.
We can do it after.
That's right. Yeah, yeah, you're right about that. She's right
I
about
like the
that.
extra points, they really help on tests.
Yeah.
They really help.
Star on the top of it.
Yeah, right.
Yeah, we
So-
can do that.
Okay, now this one right here, we should be able to do this one like without a calculator, right? 2 minus x squared, what does that thing look like?
It's upside down, up 2.
Yeah.
Okay, if we have our y-intercept of 2, so it look like this. So what's the boundedness of this thing here? Bounded above.
I think.
Oh, above.
That's what I said.
Yeah,
That's what I said, Angel.
Yeah, because see, there's upper boundary to it, so we say bounded above is how we would say this one, okay?
Why is it above?
It doesn't go above.
And then go above that line, like,
You see, if the reason it's not, so this 2 is an upper boundary. You see, we don't really have a boundary below, because if we draw it below, what is it? This thing comes right through it. So this is the maximum extent, this horizontal line,
Oh, that makes more sense.
y equals 2. So therefore bounded above, okay?
I'm gonna do the opposite.
Now.
And then this one right here, what do we call this one?
two to the power of x.
2 to the power of x, what does that look like?
Oh, like that.
What is the boundedness of this thing?
Below.
Okay, Kayla says below. Do you agree with Kayla?
No.
Yes.
Below.
Yeah,
Wait,
bounded
no.
below.
Yeah.
Wait, how do you know about that one?
See, that's all.
Oh, wait, yeah, never mind, I do.
I don't do
I got it. Because it's like,
It's just the opposite.
And then if you look at 38, what does that look like?
above,
Above.
it's just the reflection.
Just the reflection about which axis?
But
Just the one we just.
About the
did.
y-axis.
The Y.
See, this one's going to look like this.
Oh, wait, it's the same.
It's bounded above.
Reflected about the y-axis.
Below.
Bounded,
If he uses our glass.
bounded below also. Okay? And then this one here. Now this is a type of equation that you're probably not too familiar with. I'm going to want to, in pre-calculus, get you familiar with this. So if you go like this, did anybody graph this yet?
No, not yet.
Yeah, no,
No, bounded above.
Don't fit.
Bounded above.
above.
So you goes like this.
Rounded above.
All the way up there.
Calc shows up.
So what is-
Baby.
So what is this one here?
This is just.
Just zoom
one
in,
step.
just zoom in. Bound, baby.
Rounded above.
Bounded above?
Yeah.
And below.
You think it's,
Just bounded?
yeah, so bounded above, now it's harder to see, but actually there's a lower boundary too, right?
Bounded.
So we
Ooh,
just-
smart, another star.
We just say bounded here, right?
Why is it less stars?
I should have put stars too.
Yeah, error, 0, 1, 0, error.
Which?
That. That's the table.
Actually understand.
Yeah, that's the table. It's,
Bounded. It's bounded.
yeah, it's 0, 1, 0, is that what it looks like? Yeah,
0, 1, 0.
yeah, 0, 1, 0.
Subtract
So
by error.
0, 1, 0, yes. I mean, -1,
Hey,
0,
no faster.
or, anyway, bounded below. And this is the equation of a semicircle. Basically, it's radius squared minus x squared, square root of radius squared minus x squared. So that's what it is, just a semicircle. Okay, next. This one right here,
It's bounded.
bounded.
Nope.
Both ways.
Okay, what you're going to get for this one is you're going to get x times quantity 1 minus x squared, which is going to be equal to x times 1 minus x, 1 plus x. And so what you have is you have zeros at -1, 0, and 1. And this is going to be a negative function. So does negative start high, end low, or start low, end high? Starts high, ends low.
Start high and low.
So we're going to go like this. Okay, is this one bounded above, below, bounded, or not bounded?
Neither.
Neither.
Not.
Not bounded.
What's bounded on its domain?
That's not
That's what I said.
I thought it was bounded.
No, it's not.
We said not.
Cause it keeps
It's
going both
not.
ways.
Yeah, it's infinity, infinity.
You not.
Yeah.
It's half bounded. This is bounded right there, and this is right there, but then it's like halfway.
Well, can you be half and free?
Yeah, so if you restrict the domain of this function, okay, if we say for -1 to 1, right, if we restrict the domain, then the function would be bounded, right? But we don't have a domain restriction, do we? So therefore, this function is not bounded.
But if there was,
But if there were a restriction, it would be bounded.
so it's.
Okay. So, now, 41 through 46, use a grapher to find all local maxima, minima, and the values of x where they occur. Give values to 2 decimal places. So, 4 minus x plus x squared. Okay, so this is what you should look like, right?
Yeah,
Yeah.
bounded below.
Bounded below, okay.
We're doing
We're not doing that
both.
anymore.
I was just saying.
Gosh.
Yeah, so we're looking for a minimum, right? It says left bound, and we're already to the left of the vertex, right? So you can just press enter and then go to the right and enter, enter. So it says 0.4999999. So it's 0.5. What happens is, it's kind of an idiosyncrasy of these calculators, and that you're gonna get you get an error, it's not an error message, but it's a rounding error.
Yeah.
So it's really 0.5, because that's gonna be like 1/1,000,000th off of 0.5. So it's a minimum of 3.75 where x equals 0.5. So minimum of where
Can you not just write it like a point? Like minimum is 0.5, 3.75.
Yeah, well, here it is. Okay, remember the coordinate pair is like 0.5 comma
Yeah.
3.75. Is that what you put?
Yeah.
Well, so here the thing about it is, look at the way the problem is worded. It says, give values rounded to 2 decimals. It says, find all local maximum, minima, and the values where they occur. So the way the problem is worded, I want to answer as closely as I can to the original instructions. So I want to say, okay, the minimum of 3.75 and where x equals 0.5. So what happens is if you don't say it this way, then just putting the coordinate pair assumes that whoever reads this understands what that is, which they may or may. So try to answer the question in terms as accurate as you can the problem was asked. Does that make sense? That's all.
That's a lot of words. Yeah, just telling you. But I guess I'll do it.
This
That's
is
a-
English.
It just makes sense more to me, like,
It is an English class in this respect, is that we use mathematics to communicate. And so there's going to be an interface between the symbology and translating back and forth to English. Mathematics was only possible because the language was, English in this case, was robust enough to support, because you can only have symbols of language, right? So
Something like that.
anyway, so this one here, you get x cubed minus 4x plus 1, right?
Where do we find the minimum?
Okay, a graph right here. And here this is what it looks like. Is that what you got, Angel?
Yeah.
Okay, let's go. You're trying to find the minimum?
they're gonna be 2.
Okay.
Okay, we got a maximum here and a minimum, right? So second trace, I'll find the maximum first because it's on the left. So we go over here to the left of the thing. Okay, press enter, then go to the right, press enter twice. So we get negative 1 point, it says to the nearest 200ths, right? To the 100th place, right? Or 2 decimal places. So we have negative 1.15 comma 4.08, right? And this is where a maximum occurs, right? And how do we find our minimum? Same type of thing. We go to this case, put minimum, right? Okay, come here, press enter. So we have x is 1.15, y is negative 2.08. Okay, so we have a max of 4.08 where x equals negative 1.15, right? And we have a minimum of, is it 2.08 or negative 2.08? It's negative 2.08, right? So let's fix this. There we go. Negative 2.08, where x equals 1.15. Okay,
Well, still.
Wait, you're going too fast.
Really, really fast.
okay. Next, we have negative x cubed plus 2x minus 3. Plus 2.
It's Zoe 101.
Never watched that.
I didn't either, but I still know it.
Okay, is that right?
Oh my, yeah, you can see it.
So is that what it looks like?
Yeah.
Is there anybody who has trouble finding these minimums on the calculator and so forth?
I've been told the word
All right, good job. So anyway, second trace minimum.
Will gives me a headache every day.
I think my headache is sitting next to me.
I'm sorry. Me too.
So here's our minimum and where it occurs, right? Negative 4.09.
I don't think you're gonna use this video for the 40 posts.
If you don't, I want it because it's really funny.
No, this is tolerable class today.
So you're
And
I sang the Folgers thing for like 2 minutes straight. The Folgers commercial song. Are you sure about that?
stars.
Yeah. I have a star.
Yeah, we're about out of class time. So this, then enter. So max